Check, check. Are we live? Are we live? Don't know. Refreshing the watch page. Some confirmation up in this thing. Looking for confirmation. Verify. I'm sure we're probably live already, but still need to get that verify. Yeah. Looks like we got some stream going before waiting.
One of the great challenges in this world is knowing enough about a subject to think you're right.
Beating that man right
but
there.
Not an.
We're live. Are we live? Yeah, we're live. Don't worry. Bet that thing up. All right. So what's up, Ryan Roberts? Nope, not an SC. Yepper. Hey, hey. All right. So here we go. Not gonna play none of my favorite songs tonight. No, this is a redo because I think for the New Year's stream we had a lot of savages on there, a lot of good people too, but a bunch of savages. But no, I think it was a very important video. However, that video was banned by YouTube. So if you like, if you hate YouTube banning things, it doesn't matter what the things are, but if you hate YouTube banning things, like censorship, then thumbs this video up. Okay? If you love YouTube banning things, then thumbs the video down. Okay? And we'll just see how that goes. But yeah, give it a thumbs up. If you can hear me, you should be able to. Let me just make sure. First, nope, not. Sounds like we got some audio coming through. So yeah, we're gonna do a redo because I think this was a very important video to do. And so in all of the spirits of redos, then I'm gonna I drank about 9 beers in preparation for this because we're redoing New Year's. But seriously, this is an important one. So we're gonna start it over, and I'm not gonna try to get every bit that I got in for the New Year's edition of this, but anyway, here we go. Start it off.
Yeehaw.
Yeehaw. Oh, well, actually, here's my caveat statement for the whole thing. First of all, I love this guy, even though that we disagree on some pretty basic things. I really like this guy because of the way that he operates. However, he proves himself to be guilty of his own charges, which we shall see.
Larken Rosier doing a video about the flat earth thing. Now, I know what a lot of people are going to say, oh, why would you entertain that? Why would you let anybody bring up that? It's just a distraction. And I totally sympathize with the people who say that, who say it's just a distraction, it's a stupid, ridiculous thing, you can't talk people into it, whatever else. And I totally sympathize with that, and there are a couple reasons I'm doing this anyway. First of all, I think there are a lot of people who are simply ignorant. There's a difference between ignorance and stupidity. And most of us are ignorant about most things, myself included. And so it's no sin to be...
And I will say real quick that even though he made that caveat statement that he includes himself in that statement, right? He proves it in spades because he like more or less what encapsulates this whole intro to his video is that he doesn't like ignorance and arrogance. Doesn't like either one, but when you combine ignorance and arrogance together, he really doesn't like those at all. Right? But what he proves is that he himself is guilty of those very charges, of not only being ignorant about a very, very specific thing that he's talking about pretty much in the same sentence, but he's also very arrogant about that ignorance and pretty much uses his ignorance as proof of his position, which, like, it's kind of bad. As much as I love this guy, which I do, it's pretty bad. It's bad.
Ignorant in some field of thought, and it doesn't necessarily mean the person's stupid. There's a difference between your brain doesn't work and your brain doesn't have certain information in it. So there's a lot of well-intentioned but misguided people who are being duped by these distractions and silliness, whether or not it's some intentional plan to distract people and make people believe stupid stuff, which it very well may be, or if it's just other ignorant people passing it on. So there's a reason to, like, I want to help the people who are just being duped by something that sounds interesting and they don't know enough to see through it.
Okay, so what he just said is he wants to help the ignorant people who they're very well meaning, and they hear information that they don't really understand, but they're too ignorant to understand that the information that they are agreeing with is moot. That's what he's saying. So, blissful ignorance, that's a topic that we could talk about on this, but let's keep going, because, I'm just highlighting some of these points because it will play a role in the end.
But more than that, the main topic here isn't really even the shape of the planet. It's the issue of understanding versus believing, because most people and most things they know, they don't know it. They believe it. And there's a big difference. And the people who believe things assume that everyone else just believes things. They don't think in such a way. They're not used to thinking in patterns that they even know what it means to know something, to prove something.
And, I have to say I agree with him on that point as well, because there's a big difference between believing something and knowing a thing. And many, many people, even flat earthers, are guilty of this. They're guilty of believing a thing and believing that belief as a proven knowledge. So, like, I guess what I'm saying is there's a big difference between proving a thing and believing a thing. And if you, just because you believe a thing and because the anecdotal evidence suggests that thing heavily, does not prove it. Okay? And so, like, I agree with where he's coming from. Like, this guy right here, like, he's preaching to the choir on many, many levels. But let's keep going, because this is kind of a long video, and I just did this 2 days. Well, I did it last year, in a lazy sort of way of thinking. It was a couple days ago. But let's keep going.
When most people say this proves it, they mean I saw enough confusing stuff that I'm persuaded. In mathematics and science, proof actually means something specific. It means logically ruling out any other possibility. It doesn't mean persuading somebody who doesn't really know what they're doing. Incidentally, if anybody posts memes or videos or anything under this in either direction on this issue under this, I'm going to delete it. If you can address if you go and rants about anything not related to what I'm actually talking about in this video, I will delete that too. Use your words, whether you're flat earth or round earth, use your words to actually explain things relevant to what I'm going to be talking.
Yeah, and I agree with that too, because sometimes there is certainly a place for rants. And anybody that knows me knows that, like, I am the rant mogul and everything. But there is a certain place for rants, and there's a certain place for logical or mathematical structured debate, and there's a big difference. So, like, I get that as well. And so, on the point that he's making, which we will get to soon, once I get through my rant, fuck it, let's just keep going.
About. Otherwise, it's going to get deleted because so quickly this turns into a giant pile of noise. Most of what passes for education is memorization. It's not understanding. It's people hear crap, they memorize it, they write it down on a test, they get a good grade. My father was a mathematics and science teacher for a bazillion years. And I know flat earthers will say, oh no, he's in on the conspiracy. I bring it up because he taught...
Well, and that is a bit of a point of contention. Because, yes, your father may have been a mathematics instructor. And, whatever application towards science that may have been, The thing is flat earthers are not against mathematics and science. Flat earthers are against mathematics posing as science, mathematical hypotheticals representing themselves as scientific fact. That's a big difference. So, like, even if you were a beautifully magnificent mathematician, right? Even if that's true, you might start off with a premise mathematically that is a false premise and extrapolate lots of beautifully correct mathematics from that false premise. But at the end of the day, your conclusion will necessarily be false. So the thing is mathematics only is a description of hypothetical realities, right? Whereas physics and science is a study, a meticulous study of actual reality, right? So yes, you can indeed use mathematics to describe things and even extrapolate hypotheticals, right? But that does not necessarily make your correct extrapolations correct, okay? Because if you base your extrapolations on a faulty foundation, then any conclusion you get from that is false. Okay, so let's keep that in mind as well, because that's going to be very important here in a minute, or maybe in 5.
A very unorthodox way. And it's funny because one year he was voted the most students voted for him as their favorite teacher, and the most students voted for him as their least favorite teacher, and for the same reason, which is he didn't teach the way most education teaches, which is you sit there, I'll feed you stuff, you memorize it, you barf it back out on a test, and I'll give you a good grade. He taught people to actually think. He said, here's what we're trying to figure out. I'm not going to tell you how to figure out. You have to figure out how to figure it out, and then figure it out. And he would, help along the way and give hints and stuff, but it was actually creative thinking. And the people who were used to just memorizing and spouting things back, a lot of them were uncomfortable in the class because, this isn't what I'm good at. So they're the ones who didn't like it, and the ones who actually liked to think and figure things out loved it, because wow, I actually understand this.
And that's a big point as well, because there's a big difference between one's ability to non-creatively plug in numbers into algorithms. That's one thing, but to understand the algorithm is an entirely different thing. And so, I agree with this guy on so many levels, so many. I don't want to get weird about it, but I kind of love this guy, dude. That's what I've said this, and this is the only ever video I've ever seen of this dude.
Because I made it my own, and I actually looked and figured out how, the evidence and the logic, and now I really know what it is. Most of what people know is not about them knowing anything. They took things on faith, and they memorized it and spouted it back. Now, I'm going to say two of the nicest things I can say in favor of flat earth people who believe the earth is flat. If you originally believed that it's spherical because somebody said so and for no other reason. In other words, if you took it on faith that it was spherical and...
Okay, and this is a big point, okay? Because there's a big difference between taking something on faith and being forced to believe a thing since you were a child, right? So, here's a good analogy. Could you possibly, with a straight face, say that little children take Santa Claus on faith after their parents and news agencies and their teachers trick them into believing that Santa Claus is real? Would you say that those children take Santa Claus on faith? No. That's absolutely the wrong fucking thing to say, dude. So this is the analogy that he's making. He's saying that taking things on faith, but so just let him get back to his point, because I think hopefully all y'all real ballers, all y'all trill ass people out there know what I mean.
Then later you said, maybe I shouldn't have, maybe I should question that. Good. I'm glad. I want you to be able to question everything, and especially if it was a belief for you, not an understanding. If it was a belief for you, I'm glad you doubt it. However, jumping to a different belief is not an improvement. The improvement over belief is actual understanding.
And again, the difference would be a belief would be something that you believe based on some sort of logic or evidence. But to equate that, to say that To say that the globe Earth is a belief is an understatement, because it is a belief that you're forced into believing since you were a toddler. Okay, so it's not a belief; it's a forced indoctrination. Okay, and whether or not it's true, that's regardless of whether it's true, right? So
now, now I'm going to pick on the round earthers, because most of the people who say, of course it's spherical, of course it's round, everybody knows that, they don't know how to prove it either. Most of them took it on faith. And so they're just repeating their faith. Now, most of them may have more sort of anecdotal evidence implying it
okay, first of all, I will say that this guy gets a gold star because he's the first globe earther that I've ever heard, even hypothetically in jest, picking on other globe earthers in a sort of a hypothetical jab, right? But the thing is they're not there's not all of this evidence for their particular belief. Their particular belief is supported by all of everything that the grown-ups told us. But in terms of, and we'll get to this as well, but in terms of physical evidence of all of the geological motion and all of the geological curvature that should necessarily exist if your hypothesis is true, it's a big fat cricket on that one, sir.
Indicating it, so they have reason to believe it, but they've never bothered to look into the geometry or the physics or anything and say, well, can I actually prove it? And I like to, sometimes I would, in conversations, go to the round earthers and say, can you actually give a geometric or mathematical proof that the earth is spherical? And most go, no. And that's fine. You're allowed to be ignorant of that. Most people are on both sides of the argument. They don't really know how to prove it either way. They have lots of...
And that, I agree with him on that as well. And I will stop interrupting him as much. But he is right. He has a point there that it's like, mathematically, most 99% of globe Earth believers can't prove it. They don't even know what the fucking formula is, right? But even when it comes to flat earthers, who are on average way better with this sort of thing than the globe earthers, even them, there's faults in it. So I agree with that. Okay, but here's my point. The truth is not a conglomeration of beliefs. So the truth is not contingent upon a polling of people's belief systems. The truth is the truth, whether or not people believe it, or whether or not people understand it, and certainly not whether or not people can mathematically fucking prove it. Okay, the truth is still the truth, one way or another, and there's no middle ground here. It's either one or the other. Okay, so let's keep going.
The reason is, well, there are flights over there, and we have satellites and GPS, and so they have this collection of stuff that to them indicates something, but that is not what a scientific proof actually is. And so I'm going to give an actual proof that the Earth is not flat, and I mean a proof in the scientific sense, and I'm not going to rely on anything you have to believe NASA for, or textbooks or any...
Okay. And so this is where we're going to very, very heavily part ways. But what he's saying is this is a proof you cannot debunk. You do not have to rely on NASA for it, which he's kind of going in the right direction. However, his proof relies on some fundamental assumptions, and his fundamental assumptions will be proven to be wrong.
Everybody else. You believe your own eyes, and that's it. And because it's not that difficult to do if you actually know how to do it. And so many people, again, it's people projecting their own ignorance when they say, you just believe what NASA says because they did. What they're saying is they took it on faith that it was spherical when somebody told them that, and they're assuming everybody else did too. So they say, well, if you never looked into it.
And again, there's a big difference between taking something on faith and being forced into believing that thing since you were a toddler. Big difference. Actually, it's not even in the same ballpark. It's really not even the same fucking sport.
You've never researched it. You've never blah, 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 blah. What they mean is they never thought about it. They never understood it. They never examined it. And they're projecting on everybody else the same thing, which is amazingly arrogant. to say, and people do this in science all the time when they say, there's no way to know that. Okay, we have a big...
Okay, and just hold on, I'm sorry. Not to keep interrupting this man, but I'm going to use his own phraseology later on. And this is a quote, amazingly arrogant.
Rectangle, and this one is 87 feet long, and that side is 13 feet long. What's the diagonal? Well, there's no way to know that without measuring it. Well, thanks to Pythagoras, there's a very easy way to know it. But if you don't know how to know it, okay, that's just ignorance. But if you proclaim, nobody in the world knows how to do this, how to figure this out, because I don't, that is ignorant and arrogant at the same time. And what...
Agreed with that sentiment as well. Like, I agree with this guy on so many levels. However, when you start applying his own infallible logic to his own shit, you realize he's a bit of a hypocrite.
Flat earthers, I constantly see them doing is, there's no proof of this. It's all just theory and conjecture. What they mean is they don't understand the proof, so they don't know if there is one. But to declare that there isn't one because you don't know about it is ridiculously ignorant. There are proofs. There are piles of proofs. I'm about to show you a very simple one. And then the question is just, how invested are you in your belief? I don't want you to be invested in
And you know, the thing is this has nothing to do with belief. Like, for someone from his position to say that me, as a, vocal proponent for Flat Earth, is doing this from some position of belief, is actually, sir, it's an insult. It really is. It's an insult to my intelligence, and to many others as well.
I want you to believe that the Earth is spherical. I don't want you to believe that it's flat. I want you to actually understand what you're looking at when you open your eyes looking at the world and be able to prove it. Prove it to yourself and prove it to other people. Now, before I do the actual proof, it's amazing how often flat earthers, they basically use their own ignorance as proof that the world is flat. And I don't mean they think it's flat because they're...
And would you say that statement, that certain people use their own ignorance as proof that the world is, fill in the blank, underscore, could you say that sentiment could be applied to other people other than flat earthers? Potentially, I don't know, maybe people like yourself, that whole ignorance and arrogance thing that you hate so much.
They're ignorant. I mean, they will actually use their own ignorance as the proof, because they'll say, but what about this? How do you explain this? How do you explain that thing? What they're saying is, I don't know how to explain this, I don't know how to explain this, I don't know how to explain this, therefore, that's the conclusion. You not knowing how to explain or prove or solve something is not proof that anything is true or false. Well...
Okay, but I would say on the inverse of that your false belief that you have this somehow superhuman ability to solve things with your conjecture and with your assumptions and with your straight lines and shit, that could work in an inverse way to where your false potentiality to solve these problems is actually an illusion. Okay, so it works either way is what I'm saying.
It's proof that you're ignorant in certain areas, but other than that, it's not proof of anything. And yet that's usually their thing. I'll give an example. There's a video called 200 Proofs That the Earth is Flat, or that it's not spherical. I forget which one. And it's 200 examples of people who don't understand anything about geometry. A lot of them have to do with the fact that flat earthers don't know what the words down and level mean.
And that's true. He has a point. He does have a point there. Let's just let him explain it. We'll just do
all the way don't know what they mean. If this is the Earth, the round Earth crazy theory, they think that is down. It's not. Down means towards the center of the planet. So a bunch of their complaints are, well, water always finds its level. It won't stay in a ball. It'll go down. And that's true, if you understand what down means. They say...
Well, if you understand what down means, hypothetically, if you assume that the Earth is a ball, then yes. Then down is towards the center of that hypothetical ball. Okay? And I actually agree with him that many flat earthers confuse this fact quite perversely. So he does have a point, but, this is very much a hypothetical thing when you're dealing with down on a ball. You're dealing with when, if the earth is a ball, then level is a curve. So level, a straight line, is necessarily a curve. So you better have your curve levels.
Well, the pilots who fly planes, they should have to tip the nose down to make up for the curvature of the earth. No, you don't understand what down means. Well, when you're building a road, you don't have to account for the curve. It's because you don't understand what down means. Down means towards the center of mass of the planet. Level means perpendicular to down. So on a planetary scale, this is level. This is what's level. Yes, water finds its level, and this is the level because down is towards the center of mass. And half of the proofs were just demonstrations.
But, here's the thing. And although he does have a point, for him to insinuate that all flat earthers have no conceptualization of this concept, that is an insult. It frankly is. It really is. That's an insult because, we learned about this shit when we were little youngins, bro. Okay? And for you to say that we don't understand that concept of, down being relative to your vector, relative to the axis, perpendicular to the curve or whatever. No, dude. We get it. We do get that. Okay? And yeah, there are a lot of so-called flat earthers that argue points that are moot when it comes to this particular point. So you're right. But guess what? At least one fucking flat earther gets it, bro.
That flat earth people don't know what down and level mean. And if you understand, you don't have to change the road because if you keep the road level and that's the center of the earth, it very gradually makes a circle. If you can make a road around the whole freaking world, all of it would register as level and it would make a circle because down is towards the center of mass.
Yes, and he's right. It would. Hypothetically, if the earth was a ball, that's how up and down works. Hypothetically, relative to one another on the hypothetical ball. We get it.
The planet, it's not down like this. Same thing with water finding its balance and a bunch of other things like that. But when they spout out these things, how do you explain this? How do you explain that? They're just demonstrating that they don't know how to explain things, which is fine. But to use that as proof of something, I can't explain A and B and C, therefore D is true. That's just crappy logic.
Okay, that may be crappy logic, but it is definitely better to say, hey, I can't, even if you're right, assuming that you're right on that point, it's better to say, hey, I can't explain this, I can't explain that, than to say, hey, I can't explain this, but I don't know any better, so nobody has an answer to this ever because I can't explain it, but it's not even in my comprehension that someone else could explain it. And by the way, I'm parroting you. My parody is of you on this particular point, which we will get to here in a minute. Let's get to the meat of this fucking thing because I hear my wife breathing hard in the background.
So I'm going to show you actual proof. Again, using a thing that you don't have to take my word for anything. You only have to believe your own eyes. If you know anybody anywhere who's a significant distance east or west of you, do a simple experiment where you hang a yardstick. You suspend it so it points straight down.
Okay, so all my real deal ass, gangsta ass flat earthers out there already know he's rehashing Eratosthenes. This is this guy's proof. Okay, it goes all the way back to Eratosthenes, which we ignorant ass fell off the turnip truck ass flat earthers never heard of before. So let's let him learn us some business.
On a sunny day, and you hang from the ground and you see how long its shadow is. And you mark the shadow on the ground and you measure it. And let's say this guy here says, all right, the shadow is about 1.5 feet long. If that's a yard, maybe the shadow is 1.5 feet long. And then you call somebody significantly east or west of you, somebody who can see the sun at the same time, and you say, first of all, how far away are you from me? Second of all, do the same experiment. Hold up a yardstick and hold it so it's hanging straight down, right at ground level, measure the length of the shadow. So let's say this guy says, well, I have a 4-foot shadow. Well, I have a 1.5-foot shadow. Now, if you do the simple geometry, you don't need to use sines and cosines and all that equation. I mean, you can use them if you know how to, or you can do it the old way. You can triangulate and find the exact height of the sun based on...
Okay, so you can triangulate and find the exact height of the sun. However, everything he just said is true and correct. Absolutely. If you're dealing with straight lines. Okay, so if you believe that light only ever, always, only ever travels in straight lines, then this is a correct statement. And the geometry is correct too. It's perfect, it's beautiful, the shadow angles work, and you've got triangulation. However, what if these lines aren't straight? Oh, what do you mean, John? Light only ever, always travels in straight lines. Okay, so let's just see. Let's just test that. Let's test that statement. And you can call this extreme circumstances, or you could call it a demonstration of how light does not, absolutely does not, could not, ever, never, ever travel in perfectly straight lines when it comes to traveling through a density gradient atmosphere, such as the one that we have here in this thing we call reality. Okay, so we're going to do a YouTube search for sugar, water, laser, and we're going to let the we're going to let the Curry boys tell you about it. Okay, here we go.
Hey, get closer.
Well, not
It
this.
still works. Still works.
Still
works. I don't need a new one yet.
All right, here we go. And this, again, this is to answer the question, does light only, ever, always travel in straight line paths, especially when traveling through a density gradient such as the atmosphere? Let's ask that question, and let's get the answer. And this is not a theory. This is not subjective. This is not something that I might wish to be true. This is, answer the question for yourself. Does light only ever, always travel in straight lines?
Experiment, you can actually see light bend as the density increases. You need a fish tank, 250 grams of sugar, put 3 liters of water in a fish tank, about half full, and add 250 grams of sugar. Please do not stir the mixture. Leave it like this for about 24 to 48 hours. Let the sugar dissolve on itself.
Okay, so what they're doing here is they dumped a bunch of sugar into this fish tank full of water in order to basically, the sugar is going to dissolve into the water solution, and without stirring, the heavier density, thicker liquid of sugar is going to settle at the bottom according to its own density, just as everything does. And the lighter, less dense, less sugary water is going to float towards the top. So what happens is you have a density gradient. And this density gradient, even though it is a flat surface density gradient, represents an atmosphere with a density gradient. Okay?
And as this happens, there would be a density gradient. The water at the lower level of the fish tank would be slightly denser. Now shine a laser beam, and as you bring it lower down, the light will bend. You see? Okay,
so let's ask that question again. Does this light beam here, this laser light, a very good, just a miracle representation of what the light is doing as it travels through this density gradient, is it traveling in a straight line, or is it traveling in something other than a straight line? And I will tell you, my good friend and sir, and my ladies, that the light is not, absolutely could not possibly be traveling in a straight line. The light is traveling as a curved line through the density gradient. Okay? So let's keep going.
The light is bending and becomes straighter and straighter. If you bring it down, the light bends because of the density of the sugar solution is higher below. And the bending of the light can be seen more clearly in a dark room. You can see as you bring the laser beam lower down, the light would slowly bend because of the concentration gradient.
Okay, so I think that kind of solves that one question, at least. You know, whatever your position is on this matter, we can certainly all agree after that light does not always ever always travel in straight lines. Okay, at least we can agree with that. You know, we won't get into debating on how much exactly does it curve through which density medium, but we can certainly agree that light doesn't always travel in straight lines. That is absurd. If you were to have the position that light only ever always travels in straight lines through density gradients, let alone temperature gradients, you would have the absurd position. So in terms of your triangulation here, sure, your math is right, but that is only to say if your lines are straight, sir. Okay? So you're telling me that you believe that these lines are straight, even though we already know that light could not possibly be traveling in straight lines from the source to the observer, right? That's your position? Ooh, ooh, ooh.
Distance, how far apart you are from your buddy on the phone, and based on the length of the shadows, you can make a triangle, no matter how long these shadows are. Now, I'm going to do the easiest possible example that makes the math really damn simple. It's a version of that, but it's as easy as you can get. Now, the math gets really, really, really easy if you're at the equator. If you're north or south of the equator, then you have to take into account the fact that it's, you're looking a little bit south down at the sun because it won't be all the way overhead. But I'm going to use the example of Maine. Let's say you're in Maine, and you say, all right about now, I'm going to call my buddy when the sun's directly overhead. And it isn't really directly overhead, it's south, but it's overhead as far as east and west. It's only south. It's at the top of its arch in the sky. And you're in Maine, and you say, okay, my shadow is as little as it gets. It's not at all, there's no shadow going east or west of that.
Okay, so again, and I'm sorry to keep interrupting this guy, but he's relying, his entire premise, first of all, relies upon the assumption that flat earthers have never heard of a 2,000-year-old dude named Eratosthenes. Okay, but also his assumption is relying upon his premise is relying upon the assumption that light only ever always travels in straight lines, which we know is false. Okay, so basically what's going on here is, you've got 300 miles between that observer and 300 miles between that observer. Each one of these observers is observing the celestial objects from within the atmosphere. Okay, so even though the atmosphere is literally a plane above them, a gradient plane above them, subjectively it behaves as a lens. Okay, because the atmosphere is thicker at the bottom and less thick or less and less dense the more the higher you go up in elevation, and so it literally behaves as a lens. When you've got light traveling from, say, the source light of the sun towards these observers, it's not traveling through a vacuum. The light is not traveling through a vacuum. It's traveling through the lens of the atmosphere subjectively to each of these observers. Okay, so your triangulation, your mathematics is absolutely correct, but your assumption that these people are living in a vacuum is incorrect. Okay, because light does not travel in straight lines. Maybe through a vacuum it would, okay, but not through the lens of the atmosphere. So let's keep going.
Call my buddy in Death Valley, California, because that's about 3,000 miles. It's a little short of that, but close enough. We're going to do the simplest math and say, hey, buddy, would you mind doing this experiment where you hold up a yardstick and measure the shadow it makes? And your buddy in Death Valley, California, while you're doing this live on the phone, will say, well, I measure it, and as it happens, my yardstick casts a shadow that's about a yard long. Now, I'm going to use rough numbers here. The accuracy doesn't even particularly matter. You know, we can have a 50% margin of error, and it would still be good, and we're much better than that. So your buddy in California says, my shadow is a yard long, and you're saying, I don't have a shadow at all. That makes the math ridiculously easy. Because if this distance from you to him is 3,000 miles, and the sun is directly over you, because you're pointing up to it, and his shadow is 3 feet long, that's a perfect 45-degree angle.
Okay. And, you know, what he's saying, his logic is 100% sound. It really is. If you're talking about straight line paths between the observer's eye and the source light. Okay? So this is the best analogy that I can come up with to just completely demolish what he's saying. Okay? Imagine if each one of these observers... fuck all that. Okay. Imagine a basketball court covered in bubble wrap. Okay? So the floor of the basketball court is covered in bubble wrap. And one big point I will tell you is don't try to have sex on bubble wrap. Okay? But no, really. So the bubble wrap is on top of the basketball court. And within each one of these little bubbles is liquid. Not only is it liquid in there, but it's like, say it's a saline solution that's gradient. Okay? So it's more dense saline solution towards the bottom of each little bubble. And less dense, pure water, maybe even a bubble of air at the top of each bubble. Okay? And then inside of each one of these bubbles, you have little potential observers that can look up and see things that are going on above the basketball court, right? And these little observers in the bubble wrap represent us, the observers, on the ground, in reality, inside of the bubble wrap atmosphere, if you will, subjectively. Now, there's not literally a bubble up above and around each and every one of us little observers. No, there's not literally a bubble. It is a subjective bubble, because the atmosphere behaves as a lens around each and every one of us and follows us around wherever we go. Okay? So if it's a foggy day, you know, your subjective bubble is a little tighter. You know, the fog makes it a little bit more condensed. But if it's a clear day and you're on top of a mountain, then, you know, your subjective little bubble is a bit bigger. But more or less, you've got bubble wrap on the fucking basketball court with liquid inside. So if you were to pass a light above the half court line of this basketball court and observe that from, you know, two disparate little subjective observers inside of each of these little bubbles, just pick two, do you think that they could triangulate on that source light that is passing over as it passes over? And I will answer you, based on the data that they use within their little bubbles, they would never be able to accurately triangulate on that source light, because they're looking at, well, maybe they could if they knew the refraction level of the bubble. But if they assume that the lines are straight, you know, a straight line from the source light to their eyeball in that little bubble, no, they would never be able to triangulate accurately, mathematically accurately, using that method. Because guess what? Light does not only ever travel in straight lines when traveling through a density gradient. Okay? So let's get back to this guy's video. There's a couple more points we're going to talk about. But the thing is he is completely ignorant of the fact that light refracts through the atmosphere. And yet, he is very arrogant of the fact that he knows that light is traveling in straight lines. So tell me there, Ginger Boy, about about ignorance and arrogance one more time.
That means from his shadow, he's looking at 45 degrees up to the sun, you're looking straight up to the sun, and therefore those two lines determine where the sun is. And like I said, this is the simplest the math gets. If that's 3,000 miles, and this is a 45-degree angle, then this is 3,000 miles. Which means if the Earth is flat, you and your flat Earth buddy just proved that the sun is 3,000 miles off the ground. Cool, nifty, spiffy, works fine. Excellent, good job, very scientific of you. You can do this yourself, it's really freaking easy. Then you call your buddy in Hawaii. Here's another 3,000 miles, not quite that far, but close enough for our measurements here. And you ask your buddy in Hawaii, hey, buddy in Hawaii, can you do this experiment? Hold up a yardstick and measure its shadow and say, but wait, we flat earthers are so in the know and so understanding, we're going to tell you what you're going to find. You're going to find that you're looking at the sun at about a 20-some degree angle in the sky, and your shadow will be about 6 feet long.
And what he is saying is also true. Like, there's issues with these sorts of measurements. What I'm telling you is that the issue with these sorts of measurements is not that the Earth isn't flat. It's the assumption that light only ever travels in straight lines. That's the problem. It really is. It's kind of a simple thing, okay? But somehow refraction was overlooked when it comes to these sorts of determinations.
Because for you it was 0, for him it was 3 feet, for him it'll be about 6 feet. It'll cut this angle in half. It won't be that sharp. It'll be a 20-some degree angle in the sky. And you say, this is awesome. We're going to tell you ahead of time, we the understanders of the flat earth, what you will find when you do this experiment. And your buddy in Hawaii will say, sorry, dude.
Okay, your buddy in Hawaii will say, well, dude, does light only ever travel in straight lines? Well, I don't know, dude. Maybe we should do a little bit of a demonstration. Not an experiment, because Nathan Oakley might kill us. But let's just see.
A fish tank, 250 grams of sugar. Put 3 liters of water in a fish tank, about half full, and add 250 grams of sugar. Please do not stir the mixture. Leave it like this for about 24 to 48 hours. Let the sugar dissolve on itself. And as this happens, there would be a density gradient. The water at the lower level of the fish tank would be slightly denser. Now shine a laser beam, and as you bring it lower down, the light will bend. You see, the light is bending and becomes straighter and straighter. If you bring it down, the light bends because of the density of the sugar solution is higher below. And the bending of the light can be seen more clearly in a dark room. You can see as you bring the laser beam lower down.
So basically, my point is, I could and should and will, but okay, hold on. I could totally and should end this video on this one point, that the very brilliant, lovable Ginger, his geometry is correct. His premise is correct. However, his main premise, that he believes that he can have a straight line triangulation or a straight line of sight towards a source light that is passing through density gradients to the eye of the observer in disparate points. If he believes these are straight lines, okay? And this guy, he's all sorts of wrong, bro. I'm sorry, he's all sorts of wrong, okay? And let's just keep going. Here it is.
The sun is at the horizon. It's at 0 degrees. It's just coming up over.
Okay, and by the way, let me make this point, that for the observer that's directly 90 degrees underneath the sun, so the guy on the far left, the refraction index for him would be about 0. So there is not going to be, as far as everything that I've understand about refraction, okay, if the source light is directly above the density gradient, the refraction will be 0. Now, for this guy over here, the one that's just to that guy's right, his refraction index is going to be slightly more. So let's say at a 45 degree angle to the source light through this density gradient, his refraction angle is going to be, the source light is passing through this density gradient at a different angle, so it's going to curve downward. Now, for the third observer on the right, his density gradient, his refraction, is going to be even higher than the guy in the middle. because the source light is passing through an even wider density gradient of the atmosphere. Okay, so these three guys, even though they're standing on a flat surface looking at this light source, if they assume that that light source is in a straight line path to their line of sight, although they are indeed standing in a density gradient, they're going to get the illusion that the three of them are standing on a curve. But what's actually curving isn't the ground beneath their damn feet. What's curving is the light above their heads through the density gradient. Okay, and it's a very tricky thing, but once you get it, it's beautiful. Okay, but that's what's going on. Each one of these guys is not in a vacuum. Each one of these guys is in a subjective bubble of atmosphere, and that atmospheric lensing effect gets more and more, like exponentially more pronounced the further you get from the light source, or the further the light source gets from your position, because it's passing through more of this density gradient. Do you understand? It's a curve. So for this guy, the curve is 0. For this guy, the curve is, say, 25%. Throw a number out there. And for this guy, the curve is 50%. Okay? So dude, it makes perfect sense. It is beautiful how stupid you are sometimes, Ginger.
The ocean right now, my shadow is infinite. It goes forever. It goes all the way off the island because the sun is straight across from me. That is called a proof that the earth is not flat.
No, sir. That is called a proof that light does not always, only, ever, ever, always travel in straight lines. That's it. Okay? In order to prove curvature, you're going to need to get way worse than that, sir. But you certainly did prove in spades that light doesn't only, ever, always travel in straight lines. Okay?
Because if these people were in a straight line, and this is 3,000 miles, and this is 3,000 miles, this guy would see the sun there. He doesn't see the sun there. Call him and ask if he sees the sun there.
Right, but see, the thing is, though, he's not standing in a vacuum. Each one of these observers is standing in a little bubble of that bubble wrap that I'm telling you about. Okay, it's not a literal bubble wrap. It is a subjective bubble of atmosphere that follows us, each of us, around wherever we go, no matter what, forever. Okay, it is a density gradient. Okay, and that perturbs light, and that's just one perturbance of light. Naturally, there's many others. Okay, but that's the big one, sir.
See it over there, which doesn't work on this model. This picture is false because this line and this line and this line don't intersect anywhere.
Okay, but if they were curved lines, could they potentially? Sure, they could. Absolutely. See, you're completely ignorant of the concept of atmospheric lensing or atmospheric refraction.
Where? If you just ask the Hawaii guy and this guy, oh, where's the sun? He'd say, it's sitting on top of your frickin' head because you're looking up and I'm looking straight across. The sun is basically your hat. And if you talk to this guy and this guy, their lines don't intersect at all.
And I will tell you, the ignorance of this man is palpable, okay? Because it's almost as if he's willfully ignoring the concept of atmospheric refraction and lensing. But that's one thing. You can't just not like someone, or you can't have sort of negative connotations towards someone for being ignorant. That would be a bit judgmental. But for being ignorant plus arrogant about their ignorance, that, my friend, poets write songs about that kind of shit, man.
It's like, well, that's utterly impossible. You're seeing it up in the sky. I'm seeing it below you. It doesn't freaking work. That's called a proof that the earth is not flat. So what actually explains what we see when we do this experiment? When you do this experiment with your buddies and your cell phones and your yardsticks. Golly gee, here's the guy in Maine who points straight up to look at the sun, well, a little bit south, but as far as east and west is concerned, straight up. Here's the guy in Death Valley, California who points, here's how he's standing, he points at a 45-degree angle to a sun really, really, really frickin' far away in that direction. Now the Hawaii works. He's pointing...
Okay, So, and this is the last main point that I wanted to sort of redo on my on my New Year's video here, was this point here. So basically, what he's saying is that these three observations only work on a globe. And you know what? This fucking guy might be right. They might only work on a globe that exists in a vacuum without a density gradient atmosphere. So basically, what you can do here is, do you see this curve here? The curve that he represents each of these observers standing on? If you flatten that curve out, make this curve a flat line across the center of the page, and understand that each one of these observers lives inside of a pretty much equal and inverse curve, a density gradient atmosphere that sort of behaves as a lens or a bubble around each and every one of them. The same observation points can actually work. The only way that this sort of thing only works in a globe model is if the globe has no atmosphere. Now, unless you're willing to come on the record and say that your terraqueous orb only has no atmosphere, then, sir, come on the record and say it. But I guarantee you that wherever the fuck we live has an atmosphere, okay? And that atmosphere behaves as a convex lens, literally, not figuratively, not, in sort of some sort of loose language. No, the atmosphere behaves as a lens between your eye, which is also a convex lens, but it behaves as a lens between your eye and the source light of the sun and the stars and the moon and all the other, celestial lights. So, the whole thing that you said about ignorance and arrogance at the beginning of this, well, I think you need a bit of time for introspection, sir.
Being flat to the horizon, and it's really dang far away. This model actually matches what you see when you walk out your frickin' door and look in the
If you assume that you live in a vacuum,
sky. The flat Earth model doesn't. It is provably false.
it is provably false if you believe that light only ever always travels in straight lines, which it does not. Let's test that again, and then we're going to end this. This is the end for you, my friend. Okay, but let's answer the question, and this is the question. Does light only ever, always travel in straight line paths? Let's see.
In this very beautiful experiment, you can actually see light bend as the density increases. You need a fish tank, 250 grams of sugar, put 3 liters of water in a fish tank, about half full, and add 250 grams of sugar. Please do not stir the mixture. Leave it like this for about 24 to 48 hours. Let the sugar dissolve on itself. And as this happens, there would be a density gradient. The water at the lower level of the fish tank would be slightly denser. Now shine a laser beam, and as you bring it lower down, the light will bend. You see, the light is bending and becomes straighter and straighter. If you bring it down, the light bends because of the density of the sugar solution is higher below. And the bending of the light can be seen more clearly in a dark room. You can see as you bring the laser beam lower down, the light would slowly bend.
Well, I'm not gonna be the one to put thoughts in your head, but the answer to me is that absolutely not. Absolutely not. Light will not always, ever, only always fucking travel in straight lines, bro. So, if that's your main premise, if your main premise relies upon geometry that is sound, your geometry sound, but you're assuming that these three little disparate observers exist in a vacuum. So guess what, bro? You are all the way wrong. You're so wrong. The little lump in the throat is your fucking nose, bro. Okay? Hey, Arlie, I didn't block you, man. Hey, I'm fixing to stop this stream, but I love you guys, man. This was a redo from New Year's because YouTube took my stream down, bro. But hey, man, I love you guys. Redid that. Shout out goes to this guy. And hey, man, I really do love this guy, bro. But his ignorance and arrogance is pretty much just coming out the fucking seams, dude. What the fuck? What? All right.